तो लास्ट क्लास में हम लोग देखे थे करंट का डिफरेंशियल्स और कुछ करंट के फार्मूलेस। करंट का फार्मूला हमने बनाया था क्या कि हाउ मेनी टाइप्स ऑफ करंट। पहले हमने देखा था क्या इंस्टैन्टेनियस करंट that is dq by dt. When this current is going to find, when the q is a function of time, suppose if q is given as t square plus 2 and now you have to find the value of current I at t equal to 2 second. In that case we will get I equal to d by dt equal to t square plus 2. We will differentiate this. We will get the क्या? Differentiation of t square we will get the क्या 2t and now the constant differentiation will be क्या 0. Here we get the what I equal to 2t. I equal to 2t we have to find the क्या the current at t equal to what 2 seconds. You will put the value of t here, you will get क्या 4 ampere current. This will be the क्या instantaneous current. Instantaneous current is what if you are given a discharge as a function of a time and you have to find the क्या current at the particular instant of time, then we will go for the क्या derivation of that charge given as a function of time. This is regarding the instantaneous current. Now next we have gone through what average current. Average current is what? This is nothing but the delta q by delta t. This delta t indicate the when you have given the interval of time in which we have to find the current. That current we call it as what average current. Or in general I discuss I is equal to plus minus n e by t, where q is equal to plus minus n e. If you have given the number of electrons and time is given, we will use this formula to find the current. Now also we have discussed the word regarding the drift velocity, how the current flows in a conductors. Regarding drift velocity we have discussed relationship between the current and drift velocity, that is NEA by NEA VD. Or next we have discussed what current density. This current density is also a function of drift velocity. That drift velocity current density is given by NE into VD, and VD we have derived here VD as what E into capital E by M into tau, where tau is what relaxation time. Now after that we will move toward the another topic, that is called what mobility. What do you mean by mobility? Mobility defines as the drift velocity per unit electric field. Mobility indicates the moving capabilities of charged particles. The mobility it is defined as drift velocity per unit electric field. It is also a vector quantity. It is denoted by mu, that is given by Vd by E. If we put the value of a drift velocity, that is E into E M into tau by E. E get cancelled here. You will get the mobility in the terms of relaxation time. This is mu equal to E into tau by M, where E is the charge on electrons, that is 1.6 into 10 to the power of minus 19 coulomb. M is the mass of electrons, that is given by 9.8 into 10 to the power of minus 31 kg. And here tau is what relaxation time. This indicates the time elapsed between the two successive collisions. If we talk about the unit of drift velocity, velocity unit is what meter per second. meter per second, and it is divided by what? Electric field. So electric field is given by what? Volt per meters. So if you divide this sum, you will get what? Meter per second into meter by volt. You will get what? So meter square, second inverse, volt inverse. This is the unit of what? Drift velocity. Mobility. What is that? This is the unit of mobilities. Now next, we will derive what is the relations between current density in terms of relaxation time. So as we have current density is given by Ne into Vd. Now Vd we have minus E by m into tau. So if I put the value of Vd in current density, you will get n E square E by m into what? T. So what you will get here? See, this is J, this is n E square, this is tau by m into E. What is this? This whole term is going to be constant. It means here we got a relation that current density is directly proportional to electric field, and this constant is replaced by what? Proportionality constant replaced by sigma. That sigma is called conductivity of conductors. This conductivity, where the value of conductivity is here, sigma is equal to Ne square by m into tau. This is called conductivity, and this sigma, the relationship between current density and sigma and E, this is called point form of Ohm's law. The Ohm's law, that is V equal to IR, is derived from this point form of Ohm's law. So this J, current density, is directly proportional to the electric field. This is the point form of Ohm's law. Now we will derive the Ohm's law, that is V equal to R, from the point form of Ohm's law. So we know that whenever the conductor is subjected to the external electric field, it aligns the electrons to move in a certain direction. These electrons are drifting from one ring to another ring, and the direction of the current is opposite to the direction of flow of current. We have seen in the last class. So see here I told you the external source, we have connected a battery that is of volt V. And assume here the length of the conductor is N and the cross sectional area is A. So here electric field established across the conductor, that is V by L. Due to this electric field, every electron inside the conductor experiences a force. That force is given by E into E. This force directs the electrons to move from one into another ring. So if I replace this here, we have the current density. We know I by area. Now resistivity, conductivity is defined as what? Reciprocal of resistivity. Now electric field we know V by L. Here the electric field established V by L. Now we will interchange the term. We will get what? I into L by A into rho equal to V. So what is this? Rho L by A is nothing but the what? R. So this is the V equal to IR. This is the one of the form of Ohm's law. So whenever the conductor is subjected to the external voltage source, then the current is directly proportional to the voltage applied across it, that is V equal to IR, or that V by I ratio, it become a constant, and that is the slope of this VI graph will give you the resistance value. Now, so this is the regarding the Ohm's law. So Ohm's law, in a statement it says that this experiment has done at the constant temperature. So the statement of Ohm's law is that at constant temperature the voltage applied across the conductor is directly proportional to the current flowing through the conductor. Now we will discuss some important term. What is that? Resistance, conductivity, conductance, and resistivity. Or resistivity, sometimes it is called as specific resistance. So what is resistance? So let us see what is resistance and how the resistance is going to be affected when the dimension of the conductor is going to change. So the resistance, if we talk about the resistance, so the resistance is the properties of conductor. It is the property of conductor by which it opposes the flow of current. So if we assume here a conductor having of length L and cross sectional area A, then the resistance of that conductor is directly proportional to L, and this is inversely proportional to area. If we combine these both equation 1 and equation 2, we will get R proportional to L by A. If we remove this proportionality, this I will get rho L by A. This is the value of resistance in case of conductors. So there are the three factors on which the resistance of the conductor depend upon. So what is that? First, the resistance, the factor on which resistance of the conductor depend upon. So what is the first factor? The first one is it is influenced by the length of the conductors. Second, that is the cross sectional area of the conductor. And third one is temperature. And fourth one we can say that is the nature of material. Is whether I am using as a copper or silver. So that depends upon the nature of materials. So here see, if we increase the resistance is directly proportional to temperature means if we increase the resistance, then if we increase the temperature, then the resistance of the conductor also increases. That it have a direct relation. Similarly, if we increase the length of the conductors, then the resistance of conductor also increases. It will have also a direct relations. And in case of cross sectional area, it is inversely proportional. It means if we increase the cross sectional area, that means the resistance of the conductors decreases, and vice versa. That means if you are going to decrease the resistance, means if you are going to decrease the cross sectional area, that means the resistance of the conductor increases. So this is all about the relations. How the resistance of the conductor is going to affected if you change the dimension of the conductor. If you are going to increase the length, then the resistance will be increased. If you are going to increase the area, then the resistance is going to be decreased because it has inverse relations. Or sometimes a question is asked that whenever you are stretching any wire, then suppose it is stretched to its end times. In that cases, there arises two type of question. In the question itself it is saying the volume remains same. In that case, the effective resistance of that conductor is going to be what? That one relation N nu what is equal to N square into R old. Means if a wire of having length L, when it is stretched to N times, and in that case the volume remains same. So what is the initial resistance? If we talk about the R old, suppose this cross sectional area A. If we talk about the R old value, that is rho L by A. If we talk about the R nu, what you will get? A rho. So L will become L times, and its cross sectional area is going to be decreased by A by N. So you will get here rho N square into rho L by A. So if you divide this R nu by R old, you will get here N square. So here the R nu is equal to N square of R old. This is the one expression I derived here. So that is the whenever the wire is stretched to its double or triple, that formula becomes what? R nu. That new resistance will be what? N square times of R old resistance. Next, we will talk about the temperature dependent of the resistance. So resistance in case of metal or conductors, the resistance is directly proportional to the temperature. That relations is given as temperature dependent resistance equation. Temperature dependent equation here given by RT, that is given R naught 1 plus alpha into delta T. What is RT? This is the resistance of conductor at temperature T, required temperature T, and this is R naught is the resistance of conductor at, you talk about the room temperature, or you can say the initial temperature, room temperature or initial temperature. You mention it as what? T naught. If it is T, here you mention it as what? T naught. Where delta T what? Delta T indicates that is change in temperature. Change in temperature. The delta T is given by T minus T naught. What about the alpha? Alpha it is called thermal coefficient of conductor. This alpha, that thermal coefficient for the conductor is positive. This is for conductor. For semiconductor and insulator, the thermal conductor coefficient will be negative. So it shows the negative resistance characteristics. It shows the positive resistance characteristics. That means if we increase the temperature, means the resistance value will increase in case of conductors. Similarly, if we talk about the what? Semiconductor or insulator, if we increase the temperature, then the resistance is going to decrease because of having a negative thermal coefficient. So later we will move to the next